Hello everyone, today we will talk about objects and custom types. We will start with objects. As we saw in the variables tutorial, when we declare a variable, we also set its type. So in this case we have a variable named s and its type is string. This means that it can hold string objects. There is one special type named object which can hold all other types. In this case we've declared two objects and assigned the string value to the first one and an integer value to the second one. The object type is very useful. For example, if we create a list, the list holds objects. So we can add any type we like to this list. There are two kinds of types: the value or immutable types, such as the primitives and string. Primitives are all the numeric types and Boolean. Let's see an example. We have declared a variable named x and it points to the number 100. No matter what happens in our program, as long as we are not assigning a new value to this variable, it always points to the same value. This is also true for strings. We can be certain that until we assign a new string to s, it will point to the hello string. Arrays, on the other hand, are mutable. So if we have we can change the value that I points to without assigning a new object to I. Most types are mutable. Creating a new object is done in two steps. First, we declare the variable with dim, and then optionally we call initialize. If the object exposes an initialize method, then you are expected to call it before you can use the object. In many cases, we will set the event name in the initialize method. Let's say that we want to assign the same timer, the same object instance to a different variable. While we can initialize the new variable, we don't need to. It will just create a new instance and then release it. So we can immediately assign the timer to the new variable. Both variables now point to the same timer. Note that in some cases, let's say that we have a global string builder, and at some point we want to assign a new object to this variable. So we should call dim again. It will still be a global variable, and initialize. If we are only doing it once, then there is no point in calling dim. Let's create a list of string builders. list exposes an initialize method, so we must call it. And we add the new instance to the list. Now, if we want to get a string builder from the list, we call the get method. However, let's say that we want to take the first one. Remember, the index of the first object is always 0. It returns an object variable. We need to cast the object variable to a string builder. This is done by creating a new variable, a new or existing, it doesn't matter. The for each loop is very useful when working with lists. We can set the iterator type and then we don't need to cast each object manually. Let's run our program. As you can see, the string was appended correctly to the first item, and it prints all other items as well. For this to work, the objects must be of the correct type. If we will add a number, if we add a number to the list, then it will fail. Let's see. Then you can see class cast exception, integer cannot be cast to string builder. Objects are passed by reference. Let's remove all the global variables. As you can expect, the second log it will print AAA BBB. This means that it didn't create a copy of string builder, it passed the same object instance. Now it's more accurate to say that the reference was passed by value. It is not really passed by reference. You cannot create a swap sub. You cannot create no matter what happens inside this swap sum, A's value will always be 100 and B value will be 200. In C, for example, you can get a pointer to the variable's memory location and switch the two variables. The closest thing to a swap sub is a swap sub that works with arrays. This can work. Let's see. As you can see, we didn't swap the arrays, but rather swapped the array's contents. This is very similar to a pointer. Let's go over to common mistakes. We have a list. And we want to make it a table. Each row will be an array of 2 strings. Now we will print the list contents. And the output will be not what we expected. The reason is very simple. In this for loop, we only modified the same array instance and added it 10 times to the list. We can solve it by moving the dim line into the loop. This means that a new array will be created every iteration. Now it's correct. Another option, which I think is more elegant, is to use the array keyword to create a new array. Simpler and also correct. Let's say we have 2 numbers. This will print true if the condition is evaluated to true, or false if not. And it prints true. However, if we cast the 2 values to objects, it will be false. The reason that it is failed is that the compiler doesn't know the object types, and because the actual type is different, the result is wrong. Seems to be wrong. Note that if we change it to change the condition to check whether the first one is greater than the other, it will work because the greater operator can only work with numbers, so the compiler will cast the objects to numeric types. Now in this example it looks strange to use objects, but it can happen that you try to compare two objects from a list and it fails because the type is unknown. The solution is to first get the value to a variable with the correct type and then compare them. Our next topic is custom types. In many cases, it makes sense to build our own types based on our program requirements. Let's see an example. I've defined a new type. The type name is person and it has 3 fields. A user-defined type or a custom type is a lightweight version of classes. Classes will be covered in a different tutorial. Custom type is made of the type name and the type fields. That's it. Types must be declared in the global sub of any module, and all types are public, which means that you can use a type declared in a different module. I do plan to add support for private types, but for now all types are public. Once we've declared a type, we can use it. It appears like any other type. We should initialize the type before we use it. There are cases where you can use it without calling initialize, but the general rule, it is better to always initialize. In many cases, I like to add a create sub. So I've created a sub that expects the type fields and return a newly created person. I can then replace the code with a nice feature of custom types is that it is very simple to serialize the type into an array of bytes. Now this makes it simple to save the type instances to a file. Let's see an example. It is done with B4X serializator. First we need to add a reference to the random access file library. Let's add a few person instances. We will create a serializator object. Convert object to bytes. We will convert the complete list. And we will save it to a file. It will be a binary file. Write bytes and close the output stream. This is the file. Doesn't look very interesting. Let's read it now. So this keyword reads the complete input stream and returns an array of bytes. It also closes the input stream. Convert bytes to object. And now we will log all the objects. It is better to use for each loop in this case, but I want to show you the other option. Let's run it. And you can see that we have succeeded to write a list with 100 persons to a file and then read it again. Another feature of user-defined types is the ability to sort a list of types based on one of the fields. We will see an example. Let's see an example. I'm adding a CSV file, comma separated value file, downloaded from World Data Bank site. Let's see. As you can see, there are three fields in this type: country name, country code, and the population at 2016. We will use the string utils library to read this file. Load CSV. We will use this option that loads the first row as the headers. So we need to we have added the file to the files type, and the files type to reference the files type. These files will be embedded in our compiled program, and the folder name is dir assets. Separator character. Oops. Let's create a country type. No need to add country here. We are only interested in these two fields. Each item in this list, in the data list, is made of an array of strings. We can see it in the load CSV documentation, I believe. Loads a CSV file and stores it in a list of string arrays. Now let's see the fields again. We are interested in the first field, index 0, and the population field. The index will be 2. Let's test it. And there is a mistake, of course, because it should be string. Same error over here. Empty string, okay. So another error. Let's see. Eritrea. Let's find it. As you can see, the field, the population field is empty here, so we cannot parse it to a number. Let's add a safety check. Equals false. Then continue. Continue means that it will continue with the next iteration. And of course we need to add the country to the list. Okay, now it works. There is a large list with all the countries, their names, and the population. As you can see, the data is not sorted in any way. It's the same order as the order of entries in the file. We can sort it. And we will sort it based on the name field. Ascending. Let's see. Now it is sorted based on the name. Let's see. Let's sort it based on the population. Descending this time. In this case, we will format the output ourselves. It starts from here. You can see that there are regions in the list. The first country should be China, then India. There are two issues that we need to fix. Let's start with better formatting the population. I'm only doing it to add the grouping character to make the numbers more clear. As you can see, while China is the most populated country, there are other regions in the list, and you can see that all of the top regions seem to have the same population, which is of course incorrect. The reason for this is that the int data type goes from -2 billion to +2 billion, and this is the exact value. If you like to work with bits, you can always find this number with this hex number. All the bits are 1 except of the first one, which is the sign bit. There should be 7 Fs here. Same number as before. So to fix it, we will change the field to long. Now you can see that it makes sense that the first entry is the word population. The second error is here. There is an encoding issue. This means that the file was not a UTF-8 file. Let's try to convert the file to a UTF-8 file. Convert to UTF-8 without BOM. Save. And this time it is encoded correctly. Let's build a linked list. A linked list is made of items where each item points to the next one. So each item has a value, and it points to the next item. I'm declaring the head item. And we will have another variable for the last item. When the list is empty, the last item points. When the list is empty, the last item is actually the head item. Now, we always add new items to the end of the list. When a new item is added, we take the currently last item, set its next item to the newly created item, and change the last item to point to the new item. And now we will go over all the items. And let's test it. As you can see, we have successfully added 4 items and then printed all 4 items. I think that it is worth explaining this sub again. First, we create a local variable and set it to point to the first item after the head item. Now it might be an uninitialized object if the list is still empty. While the list item is initialized, we print it and move to the next item. So it will continue like this until it reaches the first uninitialized list item. That's it.